Good morning. My name is Alfred Esperida.
And I'm Josephine Soriana.
And we're from ACLC College of Sorsogon.
And our topic is about flash storage. And we will discuss about what is flash storage and the difference between the SSD and the HDD. And we will also discuss about the difference of flash storage and the enterprise.
We're also going to discuss about the extreme IOs and the definitions of flash storage.
Our topic is about flash storage. So what does flash storage means? The flash storage describes any device or system that uses flash memory. It is a broad term that can describe anything from a simple USB flash drive to a complex enterprise system that uses flash memory or the flash RAM as part of the storage system. Also, the flash storage operates very highly different from the traditional hard disk drive that store data on rotating aluminum platters that are magnetically coated surfaces. Next is the evolution of flash. In these sections, it shows the innovation of flash technology. Number 1 is the ROM or the read-only memory. It is an example of a non-volatile memory, which means once the data has been written into the ROM chip, it cannot be removed and can only be read. The ROM retains its content even the computer is turned off. Second one is the EPROM or the erasable programmable read-only memory. It is a special type of memory that retains its content until it exposed to the ultraviolet light. Next is, it overcomes the permanent write-once limitation of the read-only memory. And in order to write and erase an EPROM, you need a special device called the PROM programmer or the PROM burner. The third one is the EEPROM or the electrically erasable programmable read-only memory. It is an example of a non-volatile memory, which means it retains its data content even the computer is turned off. And it could be erased by simply applying an electrical charge across its memory cells. And the EEPROM could be erased and reprogrammed without even removing them from the computer system motherboard. The last one is the compact flash. The compact flash has the ability to erase and re-record the single memory cells. Unlike the EEPROM, it had to be completely erase the data before any new data could be stored. Next is the difference of the hard disk drive and the SSD. It shows the advantages and disadvantages of these two, and it has the capabilities. The advantages of the hard disk drive is it is much cheaper than the SSD and it has the capacity of 4 terabyte. And also, the disadvantages of the hard disk drive is it is a slower performance than the SSD and it is small and it has no shock resilience. Next is the advantages and disadvantages of the SSD. The advantages of the SSD, it has a better performance capabilities than the HDD and it has a faster boot up times and file transfer is much better. And it has no noise and require less energy to run and keep it cool. And it has shock resilience. And the disadvantages of the SSD, it is smaller size and its capacity limitation only 1 terabyte. And it is also much expensive than the HDD. Next is the hybrid drives, which use both hard drives and the solid state drives. The hybrid drives, it is slower than the SSD but still faster than the HDD. And hybrid drives is less expensive to SSD and offer a greater capacity. What is flash storage in the enterprise? So, flash storage in the enterprise is a NAND or a type of flash technology, changing fundamentals in computing and storage system, and flash memory in the enterprise is believed to reduce energy consumption of storage system. Unlike a physical hard disk drive or the HDD, the NAND do not require much space, and SSD built with NAND technology provide a high level of performance in enterprise storage system. And flash storage in the enterprise there is no spinning platters or the sweeping actuator arms in flash-based SSD. And there's almost no heat generated from devices that use flash storage. And the flash-based drives having no moving parts also generate no noise. So you can imagine how their widespread use will affect not only the data center temperature but also the noise level. The more important thing is the enterprise than just the raw speed, reliability, and durability of storage. It is a well-known fact that flash storage enjoys an initial speed burst but then settles in a steady state speed. And then next is flash storage in consumer technology. In consumer technology, mobile devices including phones, digital cameras, music players, and tablets also rely heavily on a flash-based storage. And this device use the flash chips instead of a hard drive for the storage. And the flash storage also place a hard drive has a number of benefits including the size, power, and energy consumption of flash tends to reduce the heat and in turn requires a less cooling. The downside to flash storage is cost. Compared to the traditional hard disk drive, the flash storage is much more expensive because the HDD is cheaper than the SSD. The next is what is flash storage and what is used for. Flash storage is any storage repository that uses flash memory. Then, what is a flash memory? So, flash memory comes in many forms, and you probably use flash storage every day. From a single flash chip on a simple circuit board to circuit boards in your phone or MP3 player to a fully integrated enterprise flash disk, where multiple chips are used in place of a spinning disk. Flash storage is everywhere. The next is what is flash storage SSD. SSD, which means the solid state disk or the EFD, enterprise flash disk, is a fully integrated circuit board where many flash chips are engineered to represent a single flash disk. It is primarily used to replace the traditional spinning disk or the SSD are used in MP3 players, laptops, servers, and enterprise storage system.
What is Extreme I/O and how is it unique? Extreme I/O is a full-featured all-flash array that has been designed from the ground up to unlock the full potential of flash and solid-state disk. Its powerful architecture was designed to deliver the performance, reliability, and its flexibility needed in today's enterprise data centers. The Extreme I/O solution is unique in many ways, but we view performance as a key differentiator. It is scalable, consistent, inherently load balanced, and requires no tuning. Extreme I/O has inline, global, scalable, wire speed data reduction. Extreme I/O is 100% flash-based scale-out enterprise storage arrays delivers not only high levels of performance and scalability, but also brings new level of ease of use to SAN storage, while offering advanced features that have never been possible before. How does Extreme I/O lower the effective cost of flash capacity? Extreme I/O delivers a highly efficient 82% usable raw storage capacity, and this is substantially higher than other flash arrays. As a result, flash storage is more expensive than hard disk-based storage on ROGB basis. Extreme I/O system deliver more raw and usable capacity with inline data reduction, superior data protection, and thin provisioning at much higher performance than hard drives. Extreme I/O makes flash capacity cost competitive with traditional storage solutions. Extreme I/O's ground-up all-flash arrays design was created from the start for maximum performance and consistent low-latency response times. And with enterprise-grade highly availability features, real-time inline data reduction that dramatically lowers cost, and advanced functions such as thin provisioning, tight integration to VMware, snapshots, volume clones, and superb data protection. Okay, flash storage definition. First, flash memory. Flash memory is a memory storage device for computers and electronics. It is most often used in devices like digital cameras, USB flash drives, and video games. It is quite similar to EEPROM. Flash is different from RAM because RAM is volatile, while flash memory is non-volatile, read-write semiconductor memory which is used in solid-state storage devices. Flash stores data bits in cells. Next is garbage collection. Garbage collection also a form of automatic memory management. It was invented by John McCarthy around 1959 to abstract away manual memory management in Lisp. Like other memory management techniques, garbage collection may take a significant proportion of total processing time in a program, and as a result, can have significant influence of performance. Garbage collection accumulates data blocks previously marked for deletion, performs a whole block erasure on each garbage block, and returns the reclaimed space for use. Next is SSA or solid state array. The SSA category is a new subcategory of the broader ECB storage market. SSAs are scalable, dedicated solution based solely on solid-state semiconductor technology for data storage that cannot be confirmed with HDD technology at any time. Next is SSD or the solid-state drive. SSD, also known as the solid-state disk, though it contains no actual disk nor a drive motor to spin disk. SSD is a solid-state storage device that use integrated circuit assemblies as memory to store data persistent. SSD technology primarily use electronic interfaces compatible with traditional block input-output hard disk drives, which permit simple replacement in common applications. Additionally, new I/O interfaces like SATA Express have been designed to address the specific requirements of the SSD technology. SSD, or the solid state storage that may utilize traditional HDD form factors such as 3.5-inch, 2.5-inch, and 1.8-inch. Solid state drives typically use storage interfaces such as SATA, SAS, or fiber channel. Next is solid state storage, or the SSS. SSS, it is a type of computer storage media made from silicon microchip. SSS stores data electronically instead of magnetically, as spinning hard disk drives or magnetic oxide tape. SSS is any storage capability that is provided by non-moving memory technology rather than moving magnetic or optical media. Solid-state storage typically possesses the property of non-volatility and may take various forms such as solid-state drives, solid-state cards, or solid-state modules. Typical interfaces used include SATA, SAS, fiber channel, or PCIe. Next is throughput. In general terms, throughput is the rate of production or the rate at which something can be processed. When used in the context of communication networks such as Ethernet or packet radio. Throughput or network throughput is the rate of successful message delivery over a communication channel. Throughput also is a measure of the amount of data that can be transferred from a device or transferred to a device within specific time period, typically measured in megabytes per second or Mbps. Throughput is indicative of the performance of a device in an application generating sequential reads or writes. Next is wear leveling. Wear leveling, it is a technique of prolonging the service life of some kinds of erasable computer storage media, such as flash memory used in solid-state drives or SSDs and USB flash drives. Leveling is a set of algorithm utilized by a flash controller to contribute writes and erases across flash cells. The purpose of wear leveling is to delay individual cell wear-outs and prolong the useful life of the flash-based storage devices. And last is the write amplification. Write amplification is an undesirable phenomenon associated with flash memory and solid-state drives, where the actual amount of physical information written is a multiple of the logical amount intended to be written. Because a previously written non-flash memory location must be erased before it can be written, the number of write operation within flash solid-state devices typically exceeds the number of writes used by the host. This write amplification can be represented in equation form. Write amplification equals data written to flash divided by data written by host. That's all. Thank you.